Hey everyone, Matthew Sanabria here from Oxide. I lead the solution software engineering team here, and we are focused on taking that GTM and customer feedback and taking them and making them engineering projects and building integrations. I myself have a decade of cloud and on-prem experience in site reliability engineering roles and software engineering roles, and today I want to talk to you about integrations. So I want to start with platform integrations. So what exactly are these platform integrations that we're building at Oxide? Well, these are these integrations that enable platform teams to develop on top of Oxide. As Brian and Steve already noted, Oxide is API driven, it's API first. We have our own UI, our web console, where users can interact with Oxide and create resources. But your engineering teams, they're not going to use the UI to do this sort of scale integrations that they're meant to do for your business. So these integrations are familiar across cloud providers. And I want to cover the following. We have a Go SDK, a Terraform provider, and a Packer plugin. And I'll do that with a demo. So in the UI here, you can see that I have Oxide open here, and I have some instances running. I'm just going to show you a quick demo of the Go SDK. So here I have a main.go file, which is building it's connecting to our Oxide rack, and we have this published publicly. And what this is doing is it's allowing people to integrate with Oxide's rack via a programmatic way. So how does this all work? Well, if you click the docs in our website, in our instance, you can see that it takes you to our Oxide docs. We publish an API, all the documentation for it, and more importantly, we publish an API schema. So we generate our API with an open API schema, and you can use that to generate any number of SDKs. And that's what we do internally. We have a Rust SDK, a TypeScript SDK, and a Go SDK. So this is me using this Go SDK. So if I actually run this, so if I do go run, and I'll give it the project and the SH key, this will reach out to Oxide, and this will go ahead. If I go back over to my UI here, this is going to go ahead and create this Cloud Field Day Go instance using the Go SDK. And that's great. But what happens when you want to manage the state about this? If I'm an engineering team integrating, I need to write extra code to manage the lifecycle of this machine, right? If I rerun this Go program, it's just going to create another instance and another instance. There's no management of the state. And that's where something like the Terraform provider comes in. So I'll go ahead and go to the Terraform, and I'll do Terraform apply. So now we're using this Go SDK to create our Terraform provider. So under the hood, Terraform is calling our Go SDK, which is in turn calling our Oxide API. And now not only can I get an instance created, but the state of this is going to be managed. So this is creating the disk first, and then creating the instance to boot from that disk. But now operators have control over the state of their machines. So I can go ahead and destroy that, and I'll leave that running in the background. But also, there's more integrations. For example, let's say you are running an engineering team and they need to build images for Oxide, specifically images that bake in application or business-specific logic. Well, we have a Packer plugin to do just that. So Packer is a way to build images for different cloud platforms. We created an Oxide cloud plugin for this. So if I run Packer build, this is going to reach out to Oxide. It's going to say, hey, I would like to create an instance from a base image. And then that instance will be, you'll see that coming up right here. And it's going to, once that image is started, it's going to connect to that image over SSH, and it's going to provision that instance. And this is where you would put your application-specific logic in, such as applications, system to unit files, whatever you need for your business to have in the image. And then once that image is created, and I will grab a pre-created image name real quick, because I don't want to wait the minute 45 for Packer to finish running. But once that image is created, and I'll go back into the Packer folder, you can use that image with something like Terraform. And you can say, hey, what image do you want to use? So now I'm creating a new instance from the image I've built with Packer that has my business logic within. And you might be saying, Matt, what business logic is inside of this? And in this example, the business logic is really just a Nginx web server that I run that says hello from Packer. So once this instance is started up, you would see like if I go to its external IP, you will see a hello from Packer, and I'll leave that in the background because I'm just waiting for the instance to start up. So between these Go SDK, the Terraform provider, and the Packer plugin, these are the integrations that operators in your engineering teams are expecting. They want to be able to build images with business logic built in. They want to be able to manage resources at scale using something like Terraform. And for those things where maybe Terraform or Packer isn't the right fit, you have the Go SDK under the hood so that you can write your custom integrations from there. And I will let that open up real quick. And you can see like, hello from Packer. This is me with that. I use Packer to load a business-specific logic, ran an instance, and my business logic is in there. Cool. So that's it for the platform integrations. I then want to cover other integrations, and I will repeat, hello, I am Matthew Sanabria again, still leading the solution software engineering team from the last 5 minutes. And our focus is on creating integrations for Oxide that customers are asking for, but not super specific to customers. We want to address the commonalities in the industry. And I want to shift focus here to something that Brian actually teed up for me, which is Kubernetes integrations. So Kubernetes integrations, they're kind of a beast, right? You have your platform engineering teams, your operation teams. They are writing their own code to work with underlying infrastructure providers. But some of those teams are standardizing on a platform. And generally, they're picking Kubernetes. And we've seen that in the last decade. So we also have integrations at Oxide to deploy and manage Kubernetes running on Oxide. And these integrations should sound familiar if you're in the Kubernetes ecosystem. So we've created a cloud controller manager, we've created a Rancher node driver, and we've created an Omni infrastructure provider. And we know that people are bringing their own Kubernetes to Oxide, but they're also probably already using a Kubernetes distribution, such as SUSE Rancher, or Talos Linux, or OpenShift. So we want to integrate with those as well. So let's demo a little bit of that. So I wanted to first demo the Cloud Controller Manager. Now, the Cloud Controller Manager, and I already pre-created the infrastructure for this previously, and I just have to run this bootstrap command. So this one is pretty interesting. A Cloud Controller Manager for Kubernetes is how all of those public cloud providers are providing you with a managed Kubernetes offering. They're using this Cloud Controller Manager integration, which is a Kubernetes-native way of integrating. And what it does is it runs all of these controllers that are meant to interact with your underlying cloud provider's API. And what does it do? It manages things like node health, load balancing, routes, and other controllers that you may want to do. So in this case, I created a Kubernetes cluster running on these 3 nodes, and I've bootstrapped it. And now if I get its kubeconfig file, real quick, overwrite. Now I have a Kubernetes cluster. And in a minute, after these nodes are running, if I do like get all, you'll see that this Kubernetes cluster is starting up 10 seconds ago. And this is kind of what I wanted to show you. So I'm glad I caught it pretty early. So if I watch this for a second and I do kubectl get nodes, and I just look at the nodes that are coming in my cluster, and this will take about 30-ish seconds, but I want to catch it here because I want to show you the point here. So I'll give this a few more moments. Yep, as you see, this is still 33 seconds old. And I can go, sorry for that, to one of these instances and show you the serial console. This is applying all of the Kubernetes components to turn these 3 otherwise seemingly virtual machines into a Kubernetes cluster. Let me go back here and give this a second. Cool. So now you see here, these nodes are not ready. And I want to catch them before they become ready. So I'm going to jump in really quickly and get to a point where I can show you them. They already turned ready. But when a Kubernetes cluster comes up, the nodes are marked as not ready because it has to do its consensus and form a cluster and say, hey, are you my co-node? Oh, yes, I am. Let's talk to each other. So that doesn't happen magically under the hood. That actually happens, and I'll show you this, via what's called a Cloud Controller Manager. One of the controllers that it runs is called the node controller. And this node controller is responsible for reaching out to the underlying cloud platform, Oxide in this case, and saying, hey, this node, does an actual instance exist in the cloud provider? Because I'm ready to mark it as a node in Kubernetes, but I don't want to do that if the cloud provider says that instance doesn't exist. So what this Cloud Controller Manager does is it reaches out to Oxide, verifies this instance is healthy and up and active, and then says, hey, yes, this instance does exist. Here's its identifier. So this will match the instance ID in Oxide. And then further controllers can now look at this and use that ID for other resources. And we'll cover that a little bit later. The interesting part about this is let's say you have a network partition in your Kubernetes cluster where you have 3 control plane nodes that are talking to each other, but there's a network partition for one of them. That's a pathological case in Kubernetes because now if Kubernetes can't say a control plane node exists, it might want to kill it and remove it from the Kubernetes cluster. But if you have a Cloud Controller Manager reaching out to Oxide as a source of truth, Oxide can then say, yes, I know you can't see the Kubernetes nodes, but I can, and it's existing and it's running. Please don't remove it from the cluster and cause some cascading failure. Cool. Let me get out of this. If you are running a specific distribution of Kubernetes, maybe SUSE or Rancher, we have integrations with that. So I will open up my Rancher dashboard here. So I have Rancher running. And if I load this up, you will see that we have what's called a Oxide Rancher node driver. Now, when you create clusters in Rancher, what happens is you can choose from a number of Kubernetes providers that you can run infrastructure on. One of them is Oxide. So if I click saying, hey, I want to create a Kubernetes cluster on Oxide, I get this nice UI saying, please provide me with the boot image you want to use, the size, and so on and so forth. Now, I will do that via the API real quick. So I'll do kubectl get nodes to verify that I'm indeed talking to Rancher, and I'll do kubectl apply-f Oxide manifest. And this manifest, I'll just cat it out real quick. This creates the configuration to boot on Oxide and the cluster config to say, hey, what version of Kubernetes you want to run, what machines you want to use, so on and so forth. So I'm booting a one node Kubernetes cluster. So now if I go back to Rancher, you'll see that this cluster is being created. And if I go to Oxide, you'll also see in a moment that this node is being created, or this instance is going to start being created right here. So now this is Rancher using an Oxide plugin that we've built to create nodes on Oxide to make Kubernetes clusters. And I won't show you the full, I won't wait for that to be ready. I'll just move on to the next thing. So outside of that though, let's say you're not running Rancher. Let's say you're using a new system out there. We have partnered with the folks over at Cydera Labs. They create a immutable Linux operating system called Talos Linux that is perfectly suited for being a Kubernetes node. And they have their own project called a Omni, which is a way to manage these otherwise, disparate Talos Linux machines and create Kubernetes clusters from them. They have an integration too, which I will show you. So I'll open up Omni, and you see here that I have this Oxide infrastructure provider hooked up to Cydera's Omni. And if I wanted to create a Kubernetes cluster, it's as simple as going to clusters, hitting create cluster, choosing the version of Talos, and now I'm specifically choosing version 1.11.3 because there was a patch in .3 that I worked with the Talos team on to get in there, and I need that. And then from here, I can say, hey, for my control plane, I really want you to spin up 3 of them, and I want you to use this Oxide infrastructure provider to reach out to Oxide to actually create the resources for it. So if I do this, and I won't make any worker nodes, doesn't matter. So now I've created that. Now you can see here my actual infrastructure provider is filled with logs because it's doing things. Omni has reached out to my provider and say, hey, I need to create 3 nodes on Oxide stat. And the provider is saying, great, I will go do that for you. So if I go back into Oxide and I refresh this, you will see these machines are starting up now and everything's live and running. So these sorts of integrations, the Cloud Controller Manager, the Rancher node driver, and the Omni infrastructure provider give us a lot of flexibility for running Kubernetes on Oxide. And in the future, as we add more things to Oxide, like a load balancer, like other controllers, we have ways now to integrate them with Kubernetes on day 0, essentially.